Hello dear students, hope you are doing well. So today we have section 2 of chapter 2. We will be talking about units of measurements and what do you mean by quantity, which units do you use, even though we have a lot of them. For example, for each quantity we have more than one unit, but we use specifically some of them, and we'll talk about why, the reason. So let's start with units of measurement. So what do you mean by measurement? When we talk about a number and a unit. So for example, let's say we have 2 kilometers. So we have the quantity, how much it is, the number, and the unit, kilometers. Okay, so that's a measurement. We use quantities to express measurements, to represent them. What do you mean by quantity? Is something that has a magnitude, so how much, magnitude, size, or even amount. Okay, so numbers, we talk about numbers. We use specifically SI units. For example, for length, we can use kilometers, we can use meters, we can use centimeters. We have a lot of units, right? But specifically, for length, we use meters, okay? For mass, kilograms. For time, second. For temperature, Kelvin. For amount of substance, mole. Electric current, amperes. Luminous intensity, candela. So each one of them have a specific units in order for us to understand each other. For example, if let's say I use meters, in Kurdistan we use meters, and let's say America, they use miles. If you do not know the relationship between them, if someone talks about the length of something, you wouldn't understand them because you do not know what a mile is, and they wouldn't know what a meter is. So scientists, all of them, they agreed on specific units. They called them SI units. Okay, so the following are the 7 fundamental SI units. You have to memorize this table, all of it together. So we have the quantity, 7 of them. Each one of them, their symbol, so the quantity symbol, their unit name, and their unit symbols. Okay, so what do you use in measurements? Let's say we do not write down 5, let's say, meters. No, we just write down number 5 and an M right beside it. So this is 5 meters. Okay, then we have SI base units. SI base units. What do you mean by base units? There are the normal units in which we can add things to it. We can add prefixes to it. For example, meter is a normal unit, is a base unit. We can add kilo to it, it will become kilometer. We can add centi to it, it will become centimeter. Okay, for example, we have a centi, the one on your left, that's the prefix. The one on your right, that's your base unit. Okay, so centi is the prefix. Centi is exactly 10 to the power of negative 2. Meaning 0.01. Okay, so instead of it, write down 0.01, and we have the meters. So 1 centimeter is exactly equal to how many meters? 0.01 meter. Okay, how would you know? You have to memorize this table. Each one of them, their prefix, the prefix, how much is it equal to? You have to memorize it. So you memorize this and the prefixes with their abbreviation. Okay, you have to memorize them. Okay, you have to know something that, let's say for example, kilo, for everything it is the same thing. It's still 10 to the power of 3, meaning if you use it with grams or you use it with meters, kilo is still kilo. So 10 to the power of 3, 10 to the power of 3. Okay, so kilogram, 1 kilogram is equal to how many grams? Just write down 10 to the power of 3. Instead of this kilo, this K, you will get the answer. So 1 kilogram is equal to exactly 10 to the power of 3 grams, or 1,000 grams. Same thing goes kilometer and meter. So write down 10 to the power of 3 instead of this kilo, because it is constant, it does not change, it's always 10 to the power of 3. So 1 kilometer is exactly 1,000 meters. Okay, but if you switch it, let's say we say 1 gram is equal to how many kilograms? So look, we have a small unit, which is the gram, and we have the big unit, or in other words, we have this base unit and we have this prefix unit. So if after you switch them, you have to change the positive 3 into negative 3. Okay, so 1 gram is equal to 10 to the power of negative 3 kilograms, or 0.001 kilogram. 3 zeros with it. Okay, same thing goes for meter. 1 meter is equal to how many kilometers? Look, kilometer is bigger than a meter, so this should be negative 10 to the power of negative 3, meaning 0.001 kilometer. 1 meter is equal to this. Okay, but if you do not memorize the table, you wouldn't know, you will not be able to answer questions and solve problems. And next we have the difference between mass and weight. We already talked about mass, in which it is the measure of the quantity of matter, so how much matter is inside an object, let's say. Okay, but weight is the measure of the gravitational pull on matter. Anything on Earth, we have gravity pulling it to itself, does not allow it to, let's say, fly away or float in the air, right? So that's the weight of that substance. So depending on what? The gravity. So the SI unit for mass, we talked about this, it's kilograms. But for weight, because it's a force, the SI unit is newtons. So weight has something to do with gravity. Mass does not have anything to do with gravity. Meaning, if you change the location, weight will change. If you change the location, mass does not change because it's not related to gravity. Okay? The devices that we use for mass, we use a balance on how to measure it. For weight, we use a spring balance. Let's talk about length. The SI unit, as mentioned in the table, as you have to memorize it, it's a meter. Okay, we have other units, for example, kilometers, miles, some countries they use it, centimeters. So kilometer, as we said, it's a big unit. Okay, so we use it for longer distances. But centimeter, it's a small unit, so you use it for shorter distances, or to measure the length of, let's say, a pencil or a book. You have to know that 1 kilometer, as we said, is 1,000 meters, but between meter and centimeter, it's 100. So 1 meter is 100 centimeters. And I have drawn a figure for you, the relationship between all three units. So we have the base unit in the middle, meter. Between meter and centimeter, because centi is 10 to the power of 2, so 1 meter is how many centimeters? 100. And here, kilometer, because kilometer is 10 to the power of 3, 1 kilometer is how many meters? 1,000 meters. So we can use these units to drive other units that we do not have. Let's say for area, okay? How would we do not have a specific unit for area, but if you know how to calculate area, it's easy for you to drive the unit from this mathematical formula. For example, area, you calculate it by just multiplying a length by width. So both of them, they are the length of something in which we measure it in meters, the SI unit. So meter times meter, meter square. Okay, for let's say volume, we have 3 sides, you multiply them, each one of them with meter, so meter times meter times meter, meter cubed. Okay, for density, you have to memorize the rule for density, in which it is mass per volume. So mass, the SI unit is kilograms. Volume is cubic meters, so the unit for density is kilograms per cubic meters. And the other ones as well do the same thing. Memorize their units and how to calculate them, the formulas, because you'll need it later on. Okay. We have something in which it is not mentioned in the table, which is pressure. Pressure, the unit, the SI unit, this is the SI unit. It's kilograms per, or divided by, meter times squares seconds. Okay, so it's basically mass per distance per time. Okay, so all of it together, and instead of writing down all of this, we write down PA, Pascal. But if the question asks you for the SI unit, you have to write this down, all of it. So kilograms per meters times second square. Volume, on the other hand, is the amount of space an object occupies. We already talked about this, but we have to know the SI unit is cubic meters. So for area is square, so to the power of 2, that's for area. For volume is to the power of 3, so cubed. These are some relationships between units. So 1 meter is 100 centimeters. If it is square, so look, double it, so 10,000. If it is cubed, triple it, so 10 to the power of 6 or 1 million cubic centimeters. But the relationship between centimeters and milliliters, they're the same thing. Meaning, if we say 1 liter is 1,000 cubic centimeters, we can do the same thing with milliliters. So exactly 1,000 milliliter. But if the question asks you to change from cubic centimeters to milliliters, they're the same thing. If we have 56, let's say, cubic centimeters, how many milliliters do we have? Same, 56 milliliters. Next we have density, in which the formula, or the mathematical formula, memorize it, mass per unit volume. Okay, so you divide mass per volume, you'll get the answer. The SI unit for mass, it was kilograms, right? For volume, it was cubic meters. So the SI unit for density, it's both of them combined. So kilograms per cubic meters. Okay. Other units we can use grams per milliliters, grams per cubic centimeters. We use this a lot. Grams per liters, it depends. But the SI unit, kilograms per cubic meters. The density for each substance is different. No two different substances have the same density. That's why you can use it to distinguish between substances. But for water, you memorize it, it's just 1. We can use this to determine whether an object floats or sinks. If it is more than this, more than 1, you put it in water, it's more than 1, the density of the object. If it is more than 1, meaning it's heavy, it will sink, okay? So more than 1 sinks. If it is less than 1, it will float because it would be too light. For density, when we mention density, we have to mention something else, which is temperature, because whenever temperature changes, density also changes. So if you increase temperature, density will decrease. That's why, let's say we say that the density of water is 1 gram per cubic centimeters at room temperature at 25 Celsius. We specify temperature. Let's go to the sample problem. It says that a sample of aluminum metal has a mass of 8.4 grams and the volume of the sample is 3.1 cubic centimeters. Calculate the density. The first step, whenever you're doing a problem, especially in chemistry and physics, write down what you have and what is unknown, what is given from the question and what is unknown, what does it need you to do to calculate. So we had mass, it was 8.4, so we write down mass is equal to 8.4. The volume in the question was 3.1, write it down. What is unknown? Density is unknown. So what is unknown? Density. Write down the mathematical formula for density, mass per volume. We have mass, we have volume, you just divide them and you'll get the answer. If we have similar units, you cancel them. Okay, if not, just write them down. So you cannot cancel grams per cubic centimeters. Okay, so you just write down grams per cubic centimeters. You use the calculator, just divide this by this, you'll get the answer. Okay, let's go to practice. Number 1. What is the density of a block of marble? So density is unknown. That occupies 310 cubic centimeters. This cubic centimeter is the unit for volume. Okay, so volume is 310 cubic centimeters and has a mass of 853 grams. So mass is equal to this. Again, write down the formula and divide your two numbers, you'll get the answer. Question number 2. Diamond has a density of this. Write it down. The question is saying, what is the mass of diamond? So mass is unknown. If you have the volume, which is 0.351. What do you do? Write down the formula here. And the question, in this question, density is known, but mass is unknown. Like, mass is unknown. So what do? Cross multiply. Because we do not have anything here, right across mass, so just write it down. And these two, they're across each other, multiply them, okay? So mass, to calculate mass, we multiply density by volume. You have density in the question, you have volume, use the calculator again and multiply them. Look at the units. Cubic centimeters, you cross it with cubic centimeters. What is left? Grams, which is the unit for mass. So you did your question correctly. Question number 3 and the last one. What is the volume of a sample of liquid? So volume is unknown. Of liquid mercury that has a mass of, so write down the mass, given that the density is this much, okay? Again, density is mass per volume. Here, look, volume it's unknown, so this one is unknown. Do you have something across it? Yes, so just switch them. So volume would be mass per density. Multiply them, cross grams with grams, we are left with milliliters. So divide these two numbers, you'll get 5.60 milliliters. Next, we have conversion factors. What do you mean by conversion factors? There are things that we use, or factors, or let's say division, that we use to change from one unit into another unit. For example, if you want to change from kilograms into grams, we have to use a conversion factor, okay? So what do you need? We have this rule in which we have the quantity which is sought, or the one that we want to change it into to get at the end, is equal to given quantity from the question multiplied by conversion factor. Let's do an example. For example, convert 0.5 kilograms into grams. The first thing that you should do, you have to write down the relationship between your two units, the one that is given and the one that is unknown. So the relationship between kilograms and grams, you have to know that 1 kilogram is 1000 grams. Write it down in the box on your right. Then what do you have from the question? 0.5 kilograms. Write it down. Multiplied by, write down your division and get these things from the relationship. Look, we have kilograms, you should have kilograms right across it. Where do you get this? How did I know that it is 1? From here, okay? So bring this here, right across it. What is left? 1000 grams here, okay? You cross your units, you'll get the answer in grams. Let's do another example. Sample problem 2. Express the mass of this much grams in milligrams and in kilograms. So we have two questions in one. Number 1, if you want to change from grams to milligrams, the relationship is 1 gram is equal to 1000 milligrams. So write down what you have from the question. We have grams, right across it, grams. Where do I get it? From the relationship. What is left? 1000 right here. So you just multiply this number by this number, divided by 1, which is the same thing, and you get milligrams. Then changing from grams into kilograms, again, the relationship, 1 kilogram is 1000 gram. Write down what you have from the question, then the conversion factor, you get it from this relationship. We have grams, right across it, grams. How many did we have? 1000. Then we have what is left, kilograms above. Look, you multiply this by 1, okay? Then divide it by 1000, which will be exactly this number. Same thing goes for the two practice questions. You have to express the length of meters and centimeters and kilometers. The relationship, write it down for both of them. Again, what do you have from the question? This much, or these many meters, times conversion factor from the relationship. We have meters should be right across, and the other one above. Same thing goes here, from meters to kilometers. The relationship is here. Write down what you have from the question, multiplied by, we have meters should be right across, which is 1000, and kilometer above. So what do? You divide it because they're right across each other, or you just say 16.45 times 1 divided by 1000. Question number 2, express a mass of 0.014 milligrams, change it into grams. This is the relationship. Write down what you have from the question. Then the conversion factor. So milligrams right across it, 1000. What's left? Grams here. So you divide these two numbers, you get the answer. This was it for today's video. I will see you guys in the next one.